Hi, everyone. Thanks again for joining us to this one more session of Mexicans in New England conversations. And this time our topic is Mexican engineering ingenuity. And we have two fantastic Mexicans that will be talking with us about what they're doing in research and innovation, Paulo Lozano and Felipe Gomez del Campo. So thank you so much, Paulo and Felipe, for wanting to share with us your expertise and the impressive things that you're doing in aeronautics here in Boston. So let me introduce each one of our guests today, and then we will begin with some questions. Dr. Paulo Lozano is the Miguel Alemán Velasco Professor of Aeronautics and Astronautics at MIT and the director of the Space Propulsion Lab. He earned both his master's and PhD at MIT. His work on micropropulsion earned a Young Investigator Program Award from the US Air Force and the Future Mind Award from Quo Science Magazine and the Discovery Channel. Paulo is a recipient of MIT's Outstanding Faculty Mentor Award for his contribution to the research experience of undergraduate students. He's also faculty director of MIT Mexico, an associate fellow of the American Institute of Aeronautics and Astronautics. He served on the asteroid mitigation and NASA technology roadmaps panels of the National Research Council. So we'll be happy to hear about all this expertise, Paulo, in a little bit. Felipe Gomez del Campo is originally from Mexico City and is founder of and CEO of FGC Plasma Solutions. He holds a visiting scientist appointment at MIT and is collaborating with the Institute to help FGC Plasma's technology take flight. He has a bachelor's in mechanical and aerospace engineering from Case Western Reserve University, as well as a master's in aerospace engineering from the same university. In 2015, he was honored at the White House by President Barack Obama as an emerging global entrepreneur. Recently, FGC Plasma was selected by NASA's chief technologist as the 2018 X Factor Innovation Award through NASA iTech. So thanks, Felipe, for being with us today. And I'm impressed how young and what big CVs you both have. So tell us a little bit, each one of you, about your background. How did you get into MIT? It's not that everyone that wants can get to MIT. So what made you get there? Paulo?
Hey, I can get started. Thank you for the flower. I'm not that young. It's just that in Zoom everybody looks young. My path to MIT was similar to many other people. I had extremely high interest in the sciences, in technology, in engineering, and as many people also in Mexico, I wanted to study aerospace engineering. And at the time that I was looking for places to do this in Mexico, it was a little bit hard since there was practically no dedicated research program in aerospace engineering. And on the other hand, I was well aware of several programs in the US and around the world that had the kind of thing that I was looking for to prepare myself better for joining the aerospace community. And it turned out that MIT offered probably what was at the time and continues to be one of the best programs in aerospace engineering in the world. And I was extremely interested about joining the institute. I tried once and I failed, but I continued to insist until actually I became a student. I obtained my master's student, as you just mentioned, and my PhD at the institute. And it was after my PhD that I stayed here as a researcher, and some of the contributions in the field I made as a researcher just after my PhD and I was fortunate enough to be hired as a professor. This was in 2006. And since then I have been, doing several things for the Department of Aeronautics and Astronautics at MIT. And again, I have been, I think, lucky, but also very well aware of the opportunities that places like MIT can bring. And I just have been able to take advantage of some of these opportunities. And I'm very happy in this position. I work every day with extremely smart students, very motivated from all over the world, including students from Mexico. And for me, that's the most fulfilling part of being a faculty member at MIT. The ability and of actually joining research programs with these outstanding and very smart students. So I guess we can continue talking more about all that, but that was my path pretty much.
Wow. Well, not many people that study in MIT get hired as professors afterwards. So you must have done a very good job there.
I hope so.
And Felipe, tell us, how did you were in Chicago, I think, and how was your path to get all and get a lab here in MIT? Tell us a little bit about it.
Sure, and thank you again, Consul, for having me here. So I think my path to MIT is potentially a little bit different than most. I actually tried unsuccessfully several times to apply. Different factors I never got into. My trajectory has been a little bit different. So I started out, the project that I'm working on was at one point a high school science fair. Then it was my undergrad and graduate research. After my master's, I worked for 2 years at a Department of Energy laboratory in the Chicago suburbs, like you were mentioning. And while there, that was basically a Department of Energy program designed to incubate startups, incubate new ideas. And we ended up writing a few proposals with a research group at MIT, with the Reacting Gas Dynamics Lab and the Department of Mechanical Engineering. And when those proposals were awarded, we decided to move basically all of our operations from this Department of Energy facility to MIT. So we now work very closely with the Reacting Gas Dynamics group at MIT on developing different technologies to improve how we burn fuel for energy and for aerospace. So to me, it's incredible every day walking through the lobby of the main MIT building, right, of Building 7, and seeing, thinking of all the incredible science that has been done here. I feel honored that I get to be part of that, especially, while we're developing new technologies which could have a big impact for aviation and for clean energy.
Great, thank you, Felipe. And so, in Mexico's aerospace industry is very new. It has, what, 15, 20 years maybe. Was that the beginning of that industry something that made you think you wanted to be working in the aerospace engineering, both of you? What made you choose this area?
So for me, at least, it wasn't necessarily starting in Mexico. I think I was maybe too young to be aware of that, not to date myself here. But I actually grew up for a little bit close to Kennedy Space Center. So I'm originally from Mexico City, but I grew up for a little bit next to Kennedy Space Center in the Orlando, Florida area. So ever since I was a kid, I would always watch the space shuttle go up. We would get out of kindergarten and go see it in recess. I think that idea of seeing what aerospace can do, and frankly how cool it is, can definitely inspire people. So I am excited about what's happening in aerospace in Mexico, and what that could mean for future generations of Mexicans who maybe see their parents or their friends or their family working in this industry and are inspired to get into it themselves, because it's going to take a very large, very skilled talent pool to continue to grow that industry in Mexico. But I think the possibilities are definitely there.
Great. Thank you, Felipe. And what about you, Paulo?
Yeah, I grew up in Mexico City, and all my life until I came here as a graduate student was in Mexico City, and in Monterrey. That's where I did my undergrad. And for me, it didn't necessarily start looking at the industry. the industrial development has been an actual interesting thing to witness while I have been in here. And I am fortunate enough that I have been able to collaborate with some of the people who are actually pursuing the development of industrial capabilities in Mexico. And that's actually one of the key things that I would like to explore more in the future. But for me, the motivation was mostly, as for many other kids, I wanted to be an astronaut. And I was mesmerized, as many others, by looking at the night sky and watching the stars and dreaming really of the things that are to be discovered in our solar system and in the universe in general through astronomy and through space flight. And you know, I always loved everything that flies, and especially spacecraft. And the robotic category of spacecraft is especially, you know, endearing to me. And that's basically the way it started, and just looking of ways to actually make your dreams come true. And for me was to pursue a career in science and engineering.
Great. Thank you, Paulo. Well, I hope that many young people will hear this program, or their parents, and they will share it with them, because you both are a very good example of how someone looking for their dream can get to build on it. Paulo, tell us a little bit about the projects you're currently working on. Reading your bio, it has to do with propulsion, but tell us a little bit about what you're working on now.
Sure. Propulsion is the discipline that allows the design and construction of the mobility engines for vehicles. And in particular, I'm interested in spacecraft propulsion. Without propulsion, spacecraft would be just, you know, pursuing Newtonian orbits around the planet, for example, in trajectories that cannot be corrected and in trajectories that cannot be moved, so that vehicles can explore other places in the solar system, for example. And you know, for me, studying propulsion was because of two reasons. One, because I think it's the heart of the spacecraft system, but also because a few years ago, there was a revolution in spacecraft systems as people moved from very large and very expensive systems that could only be acquired by big corporations or by rich countries, and move from that to very small systems, satellites that you know, are the size of a loaf of bread, for example, that are so cheap that people, individuals almost, can actually design them and build them and arrange their launch basically through government agencies. However, it was very hard for these little vehicles to have propulsion, and without propulsion, they cannot really do what they are capable of potentially. So, you know, in the lab at MIT, my students and I have been working on the design and refinement of propulsion technologies. And in particular, we're very interested in electric propulsion, which is not using chemical reactions, but using electric energy to move spacecraft around. Turns out that that's much more efficient to do than burning stuff. And it's a very advanced concept in which we basically ionize material and accelerate it using electric and magnetic fields. There was a big issue on how to miniaturize these engines so that they would fit a small satellite. And that's one of the key aspects of my research that is quite unique, in which we were able to not use the traditional approach, which was using a gas, a propellant gas, and ionize it, but instead using a liquid and obtain these ions directly from a liquid using a series of nanotechnology approaches that probably will take me forever to describe, and I'm so excited about it that will take hours. But basically, that's why I study propulsion, but you know, my eventual goal is to enable these technologies so that we can democratize space, basically, you know, provide the technologies so that people can actually use them and do useful things with them. From deployment of constellations of satellites that can provide communications and observation for people who are currently lacking that capability for a variety of purposes, from just simple communications to, you know, telemedicine, for example, all the way to research and development and exploration. For example, one of my key projects is on exploration of asteroids. For a variety of reasons, asteroids are extremely interesting because they can make you rich or they can kill you. And exploring them is essential to understand how are they, where they were born, what is the link between asteroids and the origin of the solar system. And the key idea that we have is, instead of sending a big spacecraft that costs hundreds of millions of dollars to a single asteroid every 10 years, to deploy a fleet of very inexpensive little satellites that can go to hundreds of these little asteroids and deploy them and explore them in a much more effective way. So that's one of my pet projects right now.
Wow, thanks for sharing. It's incredible. And Felipe, tell us, what about you? Tell us about your successful story as young entrepreneur. How did FGC Plasma start? I understand that what you're trying to find is a way that planes use less gas. So I suppose it also has to do with propulsion. And I suppose that in this pandemic time, your research and what you're doing is even more important than ever. Tell us a little bit about you as entrepreneur and researcher both.
Sure. So I definitely wear both hats, right? The entrepreneur sometimes, and the researcher sometimes as well, but really both all the time. We also work in propulsion, just at a little bit lower orbits, I guess, than the satellites Professor Lozano works with. So basically, our work is around finding better ways to burn fuel within jet engines or within gas turbines for power production. So fuel is combustion is just another chemical reaction, and what we do is also use ionization, right? So we use ionization to control the rates of combustion reactions or of other chemical reactions, basically to give you another tool to control how fuel can burn in a jet engine. And then ultimately, the idea is that you can use that tool to make better engines which perform better and have lower emissions, which is something that's important to all of us. Air travel grows at around 2% a year, maybe I think with a big pause because of this pandemic, but in general, decarbonizing aviation is going to be a very important part of the world's climate strategy, right? Making sure we drive our emissions down. The way essentially I got into this is also a little bit different from the typical trajectory. As I mentioned before, I was actually working on this idea as a high school science fair. Obviously, back then I had no idea what I was doing. But I ended up working on this as a sort of independent undergraduate research, which fortunately I had the flexibility to do when I was an undergrad. And at some point along the lines of doing the research, it sort of hit me that I needed to also think about the commercial applications of what I was doing. And the best way to think about the commercial applications of something is to actually have an entity, right? Something that's structured and focused on commercializing a technology, right? So I stepped from there from a researcher into an entrepreneur. But to me, all of that is being an engineer, because what I've learned is that designing, only part of being an engineer is designing a system. The other part is making sure you do everything you need to get into the hands of someone who's going to use it. And I sort of consider that all part of one technical problem. So what I've been doing for the past 7 years is working on how to take technology that we've been developing in the lab, right? This idea of using electrical discharges to change essentially how combustion proceeds in engines, and how to actually develop a product that uses that to improve different aspects of combustion for aviation. And I can also go maybe not as in depth as Professor Lozano, but for a pretty long time about the background of that. But suffice to say that it's there's always new technical challenges, both in terms of actually doing new research and then running a team and trying to have trying to keep a company going based off of a new technology, right? That still has a lot of risk inherent to it. But it's also been a very rewarding experience.
Thank you, Felipe. And Paulo, I know that we're very interested at the consulate to learn and know and make sure that our scientists here continue in touch with the scientists and universities in Mexico. And I understand that you have had an important academic collaboration with Universidad Panamericana. Could you tell us a little bit about that project?
Yeah, absolutely, and I think that you're right. It's very important that we don't lose sight of our roots in Mexico, and we promote as much as possible collaborations between, in this case, MIT and Mexico. And I am leading the MIT Mexico program, and the purpose of that program is basically to make the connections between researchers in Mexico and researchers at MIT, so that they can interact and they can join forces in preparing interesting research collaborations.
In every area?
In any area. And there are seed funds for this to happen. And actually, if you're interested, please contact us. We have been working on this for several years. We have some success stories, collaborating with local governments in Mexico, con federal government in Mexico, with universities, like in this case, and industry. And in particular, my collaboration with the Universidad Panamericana was born basically because of one of these collaborations at the MIT Mexico level at MIT. Basically, what I propose Universidad Panamericana is to work on a satellite project. It's in the same thing that I was discussing before. Now that satellites are small and relatively inexpensive, they are the perfect vehicle to actually start a research program in aerospace engineering. And Universidad Panamericana is very interested in doing that. And what I propose for them to do is to design, build, and launch their own space mission. And the mission is actually called Colibri, and you can find it online. It's very, very interesting. Many people that actually begin, working on satellites, they launch some very, small and satellites that have very limited functionality. It's basically a radio in space. Think about Sputnik, in 1957 when it was put in space. It's basically about very similar capability. But what I proposed, Universidad Panamericana, and they are doing it, is they are designing a platform that will have a scientific purpose. And the purpose is basically to measure the atmospheric density at low Earth orbits to correct for the drag that satellites suffer when they are at those low orbits. I mean, we think that in outer space is pure vacuum, no air, but it's actually when you're going around the Earth at relatively low altitudes, there is a very thin quantity of air that slows satellites down. And eventually they slow enough that they re-enter the atmosphere as meteorites. And what Panamericana is going to be doing is deploying right now one satellite, but the hope is to deploy a constellation in the future that in real time, they measure the density so that the models of the atmospheric density can be updated continuously and allow people to predict what satellites are going to be doing, where they are actually in all times. It's a very challenging problem because the metrology is required to detect the very small forces produced by the atmospheric drag at those altitudes. It has to be very fine. But these are kind of interesting problems that academics like to work on. And there is a very large group of students at Panamericana that are super engaged in this project. They are already presented their preliminary design at MIT. They were here before the pandemic, of course, presenting their project. And this year they're going to present their critical design review. which is the last step before hardware starts to be built. And hopefully we'll get to see their satellite launch into space in a couple of years.
Wow, fantastic experience. Now, both of you, you have been sponsored by NASA. What can you tell us about what it is to work with such impressive and important space agency? How did you get there, and how did you get funded by them? Felipe?
Sure. So we've actually worked with NASA in two different ways, and I always like to remind people that the first day in NASA is actually for aeronautics, so they also do things within the atmosphere as well. Our first engagement with NASA was through actually a program that they call iTech, which is run out of the Space Technology Mission Directorate, and it's basically it assembles a panel of NASA experts, so the chief technologists from several of the NASA centers. So there's not just one NASA in Houston or in Orlando. There's several NASA centers around the country. And they gather those chief technologists and they look at new interesting ideas, and they basically convene a forum for those startups to present their ideas sort of vetted by NASA. So we were fortunate enough to go through that and thankfully receive one of the awards. So that explosion, that interaction with NASA there was incredible to interact with some of the leaders in aerospace. From there, we actually ended up getting a NASA contract to further develop one of the applications of our technology to improving combustion for aviation. So that was work that we did together with MIT and has led to further investment and further funding from other agencies. One of the things that to me was incredible is the subject matter experts that NASA is able to convene to look at an idea, and as well as the technical risks that they're willing to take to fund new out-of-the-box ideas from a group of 20-something kids working with MIT. So I hope for continued engagement with the agency there as well.
Thank you, Felipe. And what about you, Paulo?
Yeah, I agree with Felipe. I think that NASA has a very large number of people that work technically on different aspects of aeronautics and space engineering and science. They are extremely capable, and they have achieved outstanding things in the past and in the present, and we see a very bright future for NASA. And it's interesting to see how the directions of NASA's investment moves along the years. And many years ago, it was going to the moon and then going and exploring low Earth orbit with the space shuttle, transporting cargo. Right now, it's going back to space, perhaps to the moon and perhaps to Mars. But very importantly is all the developments as well on science of in the solar system, exploring the moons of Jupiter and Saturn, for example. That are extremely interesting worlds over there, and also explore the cosmos through very capable observatories. And again, the people working at NASA is terrific. I love working with them. I have collaborators in practically every single NASA center, from JPL, NASA Marshall, NASA Glenn. These are the people who work on propulsion. So I am always excited to work with them. And at the same time, I participated in one of these National Academies panel a few years ago. This was the roadmaps for NASA. So it's basically an independent panel convened by the National Academies, the research arm of the National Academies, which is the National Research Council, to basically make an assessment of what kind of technologies should NASA be developing in the future to be on top of the technological development that is required for the scientific discoveries that we want to make as a community. And in that, many things, many technologies actually come afloat, things that NASA will be interested in developing things like, for example, what Felipe was mentioning are extremely important. For example, the issues with global warming and environmental engineering, they require extreme solutions for an extreme problem that we have right now. And plasma-assisted combustion and making the combustion itself more benign for the environment is something that is of absolute importance. So, transitioning knowledge, scientific knowledge that will allow, for example, burn engines in a more efficient manner, what Felipe is doing is extremely important. So, working with NASA is always fantastic. And I've been funded by NASA for many, many years. I collaborate with them all the time. There are outstanding Mexicans working at NASA, some of them on very relevant positions, and that are also helping Mexico in their own way. Maybe that's topic for a different conversation, but if we dig deep enough, we can see that there is a very strong net of a network, I would say, of Mexicans at NASA in this particular case that are connected already with people in Mexico, developing the kind of strategies that will help both NASA and Mexico in creating new technologies, new knowledge, and new commercial value.
Wow, well, that's fantastic to hear. Good news, Paulo. And it's connected to the one of the other questions I was going to ask both of you about how do you see, or what's your opinion on the aerospace sector development in Mexico? As I had mentioned, it's one of the newest sectors in Mexico's industry. But as you had just mentioned, Paulo, there is already an important network of intelligence, and because US and Mexico, we're so interconnected, our economies, but also now our industries. What can you both tell us about what you see on the Mexican side, if you have a perspective from where you are?
Sure. So I see very exciting things in Mexico for aerospace. I'm from Mexico City, but I have lots of family in Querétaro, and Querétaro is home to several plants from very big names in aerospace, including Safran and Bombardier. Bombardier has had some financial hardship, but I think the improvements in the workforce development that has taken place, as well as just proving out the idea that very complex, expensive aerospace parts can be made in Mexico at a competitive price point, I think has already shown the world that Mexico is a good place for aerospace. And I think the foreign direct investment into the Mexican aerospace industry shows that. What I personally would like to see is a growth of Mexico into more research and technology in aerospace, right? Instead of only manufacturing. So I think collaborations like what Professor Lozano has been doing with different initiatives through MIT Mexico are extremely important to foster not only manufacturing, but also development in Mexico that can be commercialized. And I think partnerships between the U.S. and Mexico, between U.S. institutions and Mexican institutions, can really help both sides and be critical to economic development in both places. We're neighbors, and there's many ways we can work hand in hand.
Thank you, Felipe.
I think one of the key aspects too, if I get one more point, it could be in telecommunications. A lot of Mexico, does not necessarily have wired broadband internet connections, and the democratization of space and new small satellites could enable improved internet access to parts of Mexico which were harder to reach before. So that's also why these small satellite propulsion technologies can be very, very relevant too.
Thank you, Felipe. What do you have to say, Paulo, on this?
Well, I think that, again, many years ago when I was looking for places to study, the aerospace industry in Mexico was pretty much non-existent. It has grown considerably in Querétaro, for example, as Felipe just mentioned, but also in other places, in Monterrey, in Chihuahua, in San Luis Potosí. There are these pushes to actually increase the production plant in Mexico. Granted, many of that is manufacturing, but now there is a trend to move towards the more design and technology development. I think that the rate of growth has been spectacular, but we cannot be blind to the effects of the COVID-19, especially in the aerospace industry. It's probably one of the industries that has been hit the hardest because of the lack of travel, basically, and in the manufacturing industry is going to have a very large impact for several years. That's the reality. Nevertheless, I think that there is still enthusiasm because not all of it is manufacturing, and there is this still incipient but also growing aerospace industry in Mexico that is dealing with this kind of problems. And Felipe just mentioned one of them, the satellite telecommunications. It's extremely important. This is a global problem. It's not only Mexico. Practically half of the world's population don't have access to high bandwidth communications. And deploying fiber optic or a wire network to provide that kind of connectivity is too expensive. That's why they don't have access yet. Satellites could bring, a solution to that. It's actually something that companies are doing right now. Like SpaceX, for example, is deploying their Starlink constellation. OneWeb is also deploying theirs. Amazon is thinking about deploying theirs. They have their own project. So, these are real things. But, in that field, I think that there is an opportunity for people in Mexico to actually propose innovative ideas on how to solve these very hard problems. So I think that we're going to continue looking into the development of the industry in Mexico, especially in those areas. And that's particularly interesting because, those are the areas that require the strongest, let's put it this way, investments in the knowledge base. So it's basically people who actually go there and design new things using creativity, the creativity of the Mexican people, which I think is probably one of our best assets, and putting into practice, that creativity for developing tools that will allow, people to actually solve interesting problems, relevant problems, especially in places like Mexico. Telemedicine, for example, is another one. I mean, the lack of medical coverage and service in Mexico is too large. And many times because, moving into these remote regions is practically impossible. But, with the communication technologies and the telemedicine and robotics, it might be possible in the future to cover a very important part of that service and that human right, basically, in places like Mexico and in other developing nations.
Thank you, Paulo. You both have stories of success. You both have been up to now very successful, but I'm sure that in several moments or in one moment you might have faced a great obstacle in continuing your careers. What message could you tell our public of when you faced that obstacle? How did you face it, and how were you able to go around it to continue being successful?
Yeah, I appreciate you saying that we both have stories of success. Maybe I think we both have stories of success because that's what's shared widely, but there are many failures behind all of those successes. I think the first time when we first got funded by NASA, for one successful grant proposal which we wrote, we had 13 unsuccessful proposals. So it's very depressing to get 13 no's for every yes. And unfortunately, science is like this sometimes, right? It's difficult to fund. It's difficult to convince people of what you're doing, and then sometimes what you wanted to work in the lab doesn't work, and you don't know why. And sometimes it does work, and you still don't know why. So there's always setbacks, right? Always obstacles that you're going to face. And at the end of the day, at least for me, it's been in being confident about what you're doing and what you want the end goal to be, and working hard, and eventually you'll get there, right? As we say in Mexico, the idea of echarle ganas, right, is working hard enough that eventually you'll get through your obstacles, and you just have to have enough conviction in what you're doing to get there. As a scientist, though, I will say that every time you face an obstacle, it's an opportunity to think about what didn't work and what you can do better, right? So if your proposal didn't get funded, there's something in there that can be improved. If your experiment didn't work, that's nature telling you something about how it works that you need to change for the next time you want to try out whatever you're doing. So I think it's having conviction in what you're doing and doing your best not to take it too personally.
Great. What about you, Pablo?
I absolutely agree with Felipe. We don't like failure. I don't think anybody likes failure. However, I think that we have to be very cognizant of our failures. We have to put them on a wall to remind us that the things that we believe in, the things that are important to us, they require a lot of work. So, as Felipe said, we have to learn from our failures, not necessarily mistakes. Maybe you did everything right, but, you just failed because you didn't get to the right point. But you learn from that and you make correction maneuvers, and then you try again. I think that there are two things that are important in this respect. One is always insist. I mean, if your math is right, the mathematics are right, if you're not violating any physical principles, if your experiments tell you that everything is going okay, or your experience tells you that everything is going okay, then insist. Because, you're always going to get some no's here and there, some negative results here and there. But if everything is consistently okay, then you should insist until something happens, until you make it work or you prove that it doesn't work. And both are successes, I believe. And again, in terms of failure, I would say that, again, I haven't met anybody successful that hasn't failed miserably at some point in their lives. Me included, whatever I have achieved, good or bad, I had my fair share of failures and disappointments. But I think that we, again, have to learn about them, correct them, and actually be proud, if we can, about them. But the most important part for me is to always be critical, self-critical, right? Don't delusion yourself about, you deserving something that you don't. Be critical of yourself. If you fail, there is a reason why you failed. So be, introspective in that sense. Think about all the things that you did and what you did wrong, and accept it. Because there's a problem for acceptance as well. And then relaunch yourself. So do it again. Insist.
And thank you for your comments, both of you. And it's true, and it applies not only to science, not only to what you're doing, it applies to every, that's part of humanity, I would say. We have to be self-critical, and we have to learn how to go ahead facing problems and facing obstacles, and redesign yourself after that. Two more questions. One is, has COVID changed your research priorities specifically, or your work is so long-term that COVID is just a small parenthesis in our lives?
I can go ahead and start with it. So I think before changing priorities, it definitely changed research operations, right? So we are just starting to trickle back in the lab. There's experiments that we're running around the country that we have essentially Zoom called into. We have meetings within my team with everyone on Zoom, even if some people are in the office, right? So operationally, it's a big impact on research, and we're sort of preparing for that to stick around for a while. I think there was a point in time where myself and many other researchers initially started thinking, what can we do, right, with our expertise to help combat coronavirus, right? As a scientist, if you see a problem, you want to help fix it, and for us, the reality there's nothing we could do. So we stepped back though and thought though was that this pandemic is clearly, right, the first most pressing global priority right now, and it's going to be solved with science. But there's other very pressing global priorities that are also going to be solved with science, and I think what we've seen right now is how natural phenomena, right, that we didn't adequately prepare for can really disrupt our life, right, disrupt the world. I think another act of nature like that could be climate change. So that has sort of framed our thinking in that we, as a species, really need to figure out how to prepare for the next, prepare or prevent, right, the next big catastrophe, right, big change like that. So it basically helps us frame our thinking that maybe though, even we're not working on coronavirus right now, we are working on preventing other very upsetting events for life on this planet, essentially, right? That there is that science, if used properly, can do really important things to improve our world for the better.
Thank you, Felipe.
Yeah, I think that's a very good point. Personally, the emergency has, of course, delayed my research, as many others. Because labs are closed and they are slowly reopening, so it modifies the logistics of how we are approaching our research. It hasn't changed the objectives, but I think that hopefully this whole pandemic actually changes the world in a positive way. I just heard Felipe say that science will solve these problems, and of course a scientific solution is what we should aim for. But I also think that this pandemic is teaching us something, and is not only that science is relevant, but that we have to pay attention to the science. And unfortunately, this pandemic is a result of a disappointing way of not paying attention to the science. It was completely preventable if the science was followed the way it should have been. I think that we're going to learn our lesson. I believe that we didn't follow the science in the rigorous way because the last time that this happened was more than 100 years ago. So people were not really, aware of how bad things can be, the impacts that it could have. I mean, we human beings live for far too short to actually have a sense of what big impact events like this will happen. But I think it's going to teach us to believe in the scientific assessment in a more careful way. And hopefully, as Felipe just mentioned, this helps us in understand the scientific implications of the next big challenges. And global warming is the biggest one. This thing is approaching like a very slow moving dinosaur ready to eat everybody up. You don't feel it because, the mean temperature of the Earth increases by just a fraction of a degree every year, but you don't have to wait much to get significant and dramatic and very unfortunately catastrophic consequences of this. It's time to act. I mean, we cannot really reverse what's happening so far, but we can certainly prevent it from being as bad as it could be. I don't like activated processes, and this is one of them.
You're right.
And we're activating it.
Very good point.
That's true, but hopefully there are many scientists like you in the world that believe that science is important and that through it we can at least prevent something for our future.
I think that there are, sorry to interrupt, but I think that there are plenty of scientists. I think that we need leaders that believe in science and technology, and we need education. We need the kids to actually, every kid is curious. and wants to learn math and wants to learn physics and wants to learn the science, I think that we need grown-ups that don't prevent the kids from learning, and tell them that it's important. You know, you can become a rock star physicist, a rock star chemist, a rock star engineer. I think that we should push for that.
Well, hopefully we can, with the help of Paulina, who is with us organizing this, be able to once again organize some STEM activity with kids once we were able, and we would love to have you as mentors for this, because precisely younger kids, it's important for them to know, not to be afraid of STEM and to be interested in exploring. And just to close, we all saw a couple of weeks ago the launch of SpaceX. How do you think this will impact the aerospace industry? How it's the first time that we do see that. We used to see it in NASA, but it was government, and now it's private. What's your take on this? Are you optimistic of the new avenues it opens? What do you think? And we can close with this.
Sure. So even as someone who is much more aero than space, I thought that was tremendously exciting. I annoyed my whole family by watching the live stream of the launch and narrating every part of what was going on. I think one of the reasons it's so exciting is it shows that, number one, space is not just for big governments, right? That private industry can play in that field, but it also shows that private capital, right, can really private capital and government investment can collaborate very effectively within aerospace to yield pretty incredible results. I think aerospace was one of the last industries where where venture capital had not really touched. And one of the reasons why is that you need comparable companies to show, hey, this is private investment that went into a company that also got money from NASA and then created a successful product, right? In this case, of course, the money came from, partially it got started off with Elon Musk's money, right? But it still shows the possibility to create a very valuable company within aerospace. And to me, that excites me a lot, because I think that's going to open up the door for new financing models and for greater availability of capital to start looking at companies in aerospace and helping to fund their development, right? So it takes a little bit away of the reliance from federal funding to develop these technologies, and it enables people to say, hey, we can take a little bit of funding from the government, or we can take some funding from the government and private money, and leverage those together to create something new that can be valuable in the market. And so I really do think that's going to open up the door to lots of commercial activity, not only in commercial space, but also in aviation, air travel, all the aspects of aerospace. And I think that's good for the whole industry. And it's also good for Mexico, because it really shows the viability of new innovative companies in aerospace, and those can, that can create a lot of jobs and a lot of economic development.
Thank you, Felipe.
Yeah, I agree. Two things about that. One is, that event proves that what Felipe is working on is actually very important. That connection between knowledge and industry. Those are the entrepreneurs, and they prove yet again that they are leading the way towards a better economy and a better industrial practice. And the other one is, I believe that SpaceX was successful mostly because they are creative and innovative. They decided to take some risks that the traditional aerospace industry will never take. Relanding their boosters, for example, advancing faster in terms of the pace at launch. Some of them look at those things as shortcuts for success. But actually they were taking significant risk in getting these things done. But at the end of the day, they took the risk, they prevailed, and demonstrated that the technologies can actually advance at a faster rate and in a more economical manner. So entrepreneurs, again, they're leading the way.
And scientists.
Yeah, together. It's important for both of them to be working together. And Felipe, I was consul of Mexico in Orlando, so I was there for the last launch of
Oh, wow.
of a rocket. So it was fantastic. I was also very excited to see that. I would go to the beach in Port Canaveral every weekend. So I did have that connection with that area too, just as you did as a kid.
It's loud. It's impressive watching those launches, right? It's incredible that that's something that people, lots of engineers got together and they designed it, built it, and it works and it flies, right? That's one of the incredible things that's one of the incredible parts of science to me.
Yeah, fantastic. Well, thank you so much, both of you, for joining us today, for giving us this almost an hour of your time to share what you're doing, your very, very important work that you're doing. And I hope that this program, as I said, we put it in Facebook Live, but we also put it now in a channel of the New England channel of public diplomacy of the Foreign Ministry. So it is a source for it to be seen by many people all over the world. So I'm sure that other scientists and other entrepreneurs and youngsters, I hope that many youngsters hear about your passion, and so they follow also their dream of becoming scientists like you in an area that is fantastic, aerospace industry. So thanks a lot, and we should continue in touch.
Thank you so much.
I'd be happy to. Thank you again. Yes.